Okay, class, let's talk about how we're going to use MATLAB to solve a nonlinear equation. Here's an equation I just made up. We can see this is a nonlinear equation. We have a t cubed term here, as well as a t to a 1.5 power. So this is definitely going to be nonlinear. Here's our plan. Here's what we're going to do using MATLAB. First things first, we're going to graph this function to find regions where the roots are located. Once we know the general area of the roots, we can use the F0 command to get some precise values for those roots. Here's what it looks like when we do that on MATLAB. First, I put in that function. There's my t 1/3 t cubed, 5t squared, 21t, 0.5, t to the 1.5, minus 26. And I don't really know where the roots are, so I'm going to plot it from 0 to 50 just to see what happens. So when we plot that, let's see what it looks like. We do a plot. Well, all right, we end up with a bunch of stuff. It doesn't look like there's any zeros out there, so we can ignore everything above, 20 or so. I don't really care about what's happened in negative time. That's not of any use to us. So I'm going to redo this plot, and let's take it from 20 on up and see if we spot any roots down there. So let's get back here. I'm going to pull that function back in. Let's change it so we're just looking at 0 to 20. And when we do that, oh, I'm starting to see some action down here. It looks like, notice the giant size on the left-hand scale. It looks like still all of our roots are less than, oh, I don't know, 10. Let's try 10 and see if that will give us some more information. Now, this is a successive approximation approach. I expect you to do the same thing when you're doing your activities, just to find where the roots are. Let's plot it from 0 up to 10 and see what we get. Hey, all right, so finally I've got a graph, which is actually useful. It looks like I have a 0 right here in the neighborhood of 2. There's another 0 up here around 5 or 5.5, something like that. And another 0 up here, oh, I don't know, between 7 and 8. Between 7 and 8. So I'm going to look for zeros in that area. Now, the way I do this, all right, let's see if I can get my editor guy going. Oh, there we go. All right, so I've put together here a little program. There's the plot command I just used. First, I'm going to set this guy up as an anonymous function so I can search for zeros later. If you want to know what anonymous functions are, go look at Chapter 7, Section 8. Chapter 7, Section 8 tells you all about anonymous functions. There's my function built right into this. And then I'm going to use the F0 command to find out where the zeros are. The F0 command is in Chapter 9, Section 1. Once again, go read Chapter 9, Section 1. So I'm going to find a 0 near 2, a 0 of function f near 2. I'm looking for a 0 of function f near 5, and a 0 of function f near 7.5. Those were the 3 spots that I spot. Oops, let's see. Let's change that so my comments are consistent. All right. So let's save this guy. All right, now what happens when I run this? Come up here and run and see what happens. And first of all, I got a figure which is consistent with what I had before. So let's get rid of that. Now, what values do I have? There's my function set up as an anonymous function. All right, and there's my three roots. My first root is at 1.98. My second root is at 5.58. And my third root is at 7.17. So that's how I can find roots of nonlinear functions.